4 astronauts were just announced for a mission to the moon. NASA called it historic, called it the next giant leap, called it the beginning of a new era. What they didn't say is that the heat shield protecting those 4 people on the way home has already failed once. What they didn't say is that the mission was supposed to land on the moon and was quietly redesigned because the systems weren't ready. What they didn't say is that the place these astronauts are ultimately heading hasn't seen sunlight in some of its craters since before life existed on Earth. Today, NASA announced the Artemis III crew. 4 names, 4 faces, 4 people who said yes to something that the agency's own Inspector General described as carrying significant risks to crew safety. This video is about what those risks actually are and why they were announced anyway. NASA Dandombe. Let's start with what everyone knows. Humans haven't walked on the moon since 1972. That's more than 50 years. The Apollo program ended, the technology was retired, and for half a century, the moon remained exactly where it always was. Close enough to see with the naked eye, unreachable in practice. The Artemis program was supposed to change that. A new rocket, a new capsule, new suits, new landers, the first woman on the moon, the next man, the return of humanity to a world we abandoned before most people alive today were born. That's the story NASA tells. Clean, heroic, inevitable. But the engineering tells a different story, and the engineering started showing cracks before a single astronaut ever left the ground. November 2022, Artemis I. Unmanned test flight. The Orion capsule launched perfectly, flew around the moon, returned to Earth. Everything worked. That was the headline. But when engineers examined the heat shield after recovery, what they found was not supposed to be there. More than 100 sites of unexpected damage. Large chunks of ablative material had broken away from the shield in irregular patterns, not the smooth, predictable erosion the design called for. Deep gouges, exposed areas, a heat shield that had burned wrong. The heat shield is the only thing standing between the crew and the temperatures of re-entry, a capsule plunging through the atmosphere at nearly 40,000 kilometers per hour, generating heat on the surface hot enough to vaporize steel. The shield has one job, and on the first test, it didn't do it cleanly. NASA investigated for years. They found the cause. During re-entry, heat accumulated inside the shield's outer layer. Gases formed and became trapped. Pressure built up, and the layer cracked and shed unevenly. They described it as a deviant heat shield. Not broken, deviant. There's a difference. As if the material itself had a mind of its own. A broken heat shield gets replaced. A deviant heat shield means the behavior of the material under specific conditions was completely different from what the models predicted. And if the models were wrong once, under conditions that were specifically designed to be controlled and observable, what happens for Artemis II, the crewed mission slated for next year? The crewed mission slated for next year, NASA made a terrifying decision. They would fly with essentially the same heat shield design, not the fully upgraded version, the same underlying architecture that had already behaved unpredictably. They modified the re-entry trajectory to reduce the extreme heating. They calculated the margins, but they are still choosing to fly it. The final data from those modifications is still being simulated, but the true upgraded heat shield, the one designed to actually fix the root problem, won't debut until Artemis III for the first time in deep space with crew aboard. The heat shield that will protect the Artemis III astronauts on the way home will have never been tested under actual lunar re-entry conditions before. The crew announced today will be the test. Now stop for a second. Let that land. The mission being celebrated today is also the first operational test of the system designed to keep them from vaporizing on entry. Not a simulation, not a model, the real thing, with 4 human lives inside. But the heat shield isn't even the most disturbing part of this mission. Because before we get to the heat shield, we have to get to the moon. And before we can get to the moon, there is a problem that forced NASA to redesign the entire mission architecture just a few months ago. The original Artemis III was supposed to land humans on the moon. 2 astronauts descending to the Lunar South Pole for the first time in history. A week on the surface, moonwalks, samples, history. That mission no longer exists. It was quietly replaced. Earlier this year, NASA conceded that Artemis III would no longer land on the moon. Instead, the mission profile was stripped down. The crew will launch into low Earth orbit just to practice docking and rendezvous with a commercial system. A rehearsal in Earth's backyard, not a lunar landing. The actual boots-on-the-ground mission was pushed to Artemis IV in 2028, at the absolute earliest. The reason given was risk reduction. The SpaceX Starship HLS wasn't ready. The Axiom spacesuits weren't ready. The life support docking procedures hadn't been tested. All reasonable, all logical, all things that should have been resolved before the timeline was locked, before the public hype, before these specific 4 people were handed their patches. NASA announced the crew today anyway. 4 people assigned to a mission whose ultimate destination changed just months ago, whose heat shield is flying blind, whose commercial lander partners, SpaceX and Blue Origin, are still racing to prove their massive architectures can even survive orbit. If the docking test fails, or if the automated systems perform unexpectedly, NASA's timeline doesn't just slip, it collapses. Artemis III is no longer a triumph. It's an aggressive, high-stakes gamble to save a multi-billion-dollar program from stalling. Tell me in the comments if you were selected for this crew today, knowing the heat shield anomalies, knowing the destination was downgraded just months ago, knowing you are the guinea pig for an untested architecture. Would you have said yes? But here's what almost no one is talking about. Everything we've discussed so far, the shield, the docking, the orbit, is just the logistical nightmare of getting there. The environment they are racing toward is something else entirely. And it's the reason this program was always going to be dangerous, no matter how many years it was delayed. The Lunar South Pole is not where Apollo landed. Apollo targeted the equator. Flat terrain, predictable sunlight, moderate conditions. A region chosen specifically because it was the safest place to put humans on an alien world. The South Pole is an architectural nightmare. It was chosen because of what's hiding there, not despite it. Permanently shadowed craters. Regions of the moon that haven't seen a single photon of direct sunlight in billions of years. Not because of a temporary lunar night, but because the extreme geometry of the poles means the sun never rises high enough to pierce the crater floors. Some of these voids have been frozen in absolute darkness since before complex life existed on Earth. Inside those craters, water ice. Billions of years of pristine comet impacts depositing frozen water into cold traps that never warm up. Water that can be split into hydrogen and oxygen. Rocket fuel. Breathable air. The essential infrastructure for a permanent deep space base. The reason NASA is going there. The reason China is going there. The reason this mission cannot wait. The resource beneath the moon's south pole is what makes it worth the risk of human lives. The first nation to claim infrastructure over those ice deposits effectively controls access to the most strategically valuable real estate in the solar system. This isn't just scientific curiosity. This is geopolitical pressure. When asked about the aggressive timelines, officials have been blunt, stating they might be early and we might be late. They were talking about China, admitting out loud what the mission architecture implies. Artemis is a superpower race, and races force you to accept compromises. China is actively pushing to send taikonauts to that exact South Pole by 2030. And their recent uncrewed lunar missions have been flawless. They land, they sample, they return. Every month Artemis delays, the margin narrows. This is the invisible weight behind the smiling faces on the stage today. But let's look at the surface itself. Because geopolitics explain why the mission is being forced forward, they don't explain what the astronauts will actually face the moment they open the hatch. The Lunar South Pole has no protective magnetic field. Earth's magnetosphere acts like a shield, deflecting lethal solar particles and cosmic radiation. The moon has nothing. Everything deep space throws at it hits the surface unfiltered. Radiation exposure on the lunar surface is drastically higher than on the International Space Station. The ISS still sits safely inside Earth's magnetic envelope. On the moon, the cosmic bombardment is raw, cumulative, and unforgiving. And then there are solar particle events. Sudden, violent eruptions from the sun that hurl waves of highly charged radiation across space in a matter of hours. On Earth, you don't even notice. On the lunar surface, with zero atmosphere, a major solar storm is a lethal death sentence within hours. The new Artemis spacesuits are engineered to provide some shielding. Some. If an unannounced solar storm hits while astronauts are out on a rover, their survival depends entirely on warning times and whether they can reach a shielded habitat block. But space weather doesn't follow a NASA schedule. Beyond the radiation, there is the thermal shock. On the crater rims where the astronauts will operate, in direct sunlight, the temperature spikes to over 120 degrees Celsius, hot enough to boil water instantly. But take one single step into the shadow of a crater, and within seconds, the temperature plummets to minus 170 degrees. A 300-degree thermal cliff in the span of a single footstep. No air to buffer it, no gradual transition. The internal plumbing required to keep a human body from either cooking or freezing solid is one of the most volatile engineering challenges in history. And these suits have never been tested in a vacuum with crew before. And then there is the dust. Lunar regolith is unlike anything found on Earth. On Earth, wind and water erode rock particles, smoothing their edges. On the Moon, there is no erosion. The dust is made of microscopic, razor-sharp shards of volcanic glass, and because of cosmic radiation, it is electrostatically charged. It clings to everything, and it destroys mechanisms. Apollo astronauts noted that after just one moonwalk, the dust had bypassed seals, jammed heavy joints, scratched heavy visors, and smelled like spent gunpowder inside the cabin. It irritated their lungs and throats, and that was after only a few hours. The long-term Artemis architecture plans for weeks on the surface. The dust doesn't go away, it accumulates. Every single exit and entry brings more glass shards into the living space, slowly degrading the seals, slowly wearing down the life support, slowly filling the air with a material the human respiratory system was never evolved to handle. You're probably feeling it now. That specific weight. Not theatrical horror, something quieter. The realization that the 4 people announced today, who smiled for the cameras, who waved to the crowd, are being prepared for an environment where every physics variable is actively trying to tear them apart, and some of those variables cannot be engineered away. NASA knows this, the crew knows this. Every single one of them said yes, with absolute clarity regarding the math. This isn't an attack on the mission, it's a clinical description of what deep space exploration actually requires. An inherent danger that gets sanitized by the corporate PR of a press conference. Because a public crew announcement is a political mechanism, it locks the timeline. It signals to Congress that the money is being spent. It creates inertia. And once those names are public, the institutional pressure to launch shifts into a dangerous gear. This is the dark lesson of aerospace history. In January 1986, NASA launched Challenger despite explicit warnings from engineers that the O-ring seals could not handle the freezing temperatures that morning. The schedule pressure won. The launch proceeded. 73 seconds later, 7 astronauts were gone. In February 2003, Columbia broke apart over Texas during re-entry. A piece of foam insulation had struck the wing's heat shield during launch. Requests by engineers to use military satellites to photograph the damage were dismissed by management. The system was trusted blindly. 7 more lives were lost. The point of failure was a compromised heat shield. 2 catastrophic eras, 2 different systems, 1 identical root cause, the pressure of the schedule outweighing the margin of engineering uncertainty. NASA's safety culture has evolved drastically since Columbia. The modern rigorous reviews, the internal oversight, the profound institutional memory of those failures are real, vital pillars of how they operate today. They do not want to repeat history. Yet the heat shield on Artemis I still behaved in a way the supercomputers didn't predict. The crew announced today will still fly on a modified architecture whose fixes have never faced raw lunar re-entry velocities. The mission profile was still fractured and rewritten just months ago. The shadow of China's space program is still lengthening. The structural pressures haven't changed, which brings us to the one question the press conference didn't answer. The question that is never allowed on the microphone. How much engineering uncertainty is acceptable when the variable on the line is 4 human lives? There is no comfortable answer. Spaceflight has always demanded the acceptance of risks that would be illegal in any other industry. Every human who has ever strapped themselves into a rocket accepted that dark bargain. The 4 astronauts announced today accept it completely. But the public deserves to see the math clearly. To know that behind the shiny graphics lies an unproven docking system, a volatile heat shield architecture, and a destination more hostile than any desert on Earth. The bravery of the crew demands honesty, not just celebration. What NASA said today: 4 names, 4 faces, a return to glory, a legacy secured. What the engineering says: an uncrewed heat shield anomaly, a pivot in orbit, untested suits, a tight political clock. Widi as winin ni as kenal lead, deep within the as a one, the sam pinao namoning none. When humans eventually return to that surface, whether on Artemis IV or a later mission, they will stand at the absolute precipice of that abyss, looking down into a vacuum that has been sealed since before the first complex organisms left Earth's oceans. And the only thin barrier between them and that ancient cold will be a suit, a shield, a network of systems built under the intense weight of a modern space race. The crew has been named. The training has begun. The countdown is no longer theoretical. This is the real mission, not the one in the press kit. 4 individuals heading toward an ecosystem that has waited in absolute silence since the dawn of time. And the only question that matters is if our engineering is actually good enough to bring them back. We are about to find out. The moon's south pole is arguably the most unforgiving terrain human beings have ever actively tried to colonize. But there is another world in our solar system, where the surface temperatures can melt lead, where the atmospheric pressure mimics the deep ocean floor, where the clouds rain pure sulfuric acid, and where early Soviet probes survived for less than 2 hours before being physically crushed into scrap metal. And yet, we are already planning to send humans there next. That story is on the screen right now.